Welcome one and all to this fourth episode of D&D Series 2. This is the series where daddy and daughter, that's why we call it D&D, we are going to program a platformer, aren't we?
Yeah.
And I'm Mike.
And I'm Zoe.
And today we will have something a little bit different than what we left you with last time. Let's take a look at what our game does at the moment.
Wait a minute. I don't think they can see you with the recording in the way.
What?
Can they see you with the recording?
But they can see this banana.
Oh.
Another thing we should mention is we're doing this live, therefore there is a bit of an audience. So let's see what's going on. Look there, Zoe. So we have at the top an orange character and at the bottom a yellow character. Last time we only had a yellow character and we only had this particular box over here. I've added one more just to have more collision and one over here to see what happens. So what I've done is I've created another controller and you can see that the two are behaving a little bit differently. The one that I made at the top goes a little bit faster, okay? And they go out of sync pretty quickly. Look at the stuff that's happening. My word, everything's wrong. Oh dear, did you see? I entered the wall. How about now? Uh-oh, that's bad. How about the yellow guy? Uh-oh, that's bad.
That's bad too.
So we need to do a few things. Now, do you think that that slidey problem that we saw is going to happen on the other side too?
No, because normally it points to the other side.
Oh, I see. So when we have zero input, our raycasting points to the right. And that's why we can't slide into here. But we can do it on the other side because when we stop using input, zip, oh dear, we're inside. Now first, let's start fixing the whole synchronization issue. One is going slower than the other, etc. And I'll explain why now, okay? Because before we made a pretty silly mistake. Well, I did, really. Which is we put all of our physics in update. And why is that bad?
Because update goes faster than the physics.
Well, it can go faster. It goes at an uneven pace, usually much faster, yes. Whereas the physics update, do you remember what it's called?
Fixed update.
Yes, fixed update. It goes at a very specific interval, which you can decide. I don't remember where the option is, but it's somewhere. I think that by default, it's 0.02 seconds. Therefore, it updates the physics during those times. So, let's see. Here was the code that we had before in update. You see, here we're doing all of our physics stuff. Movement input controls the velocity. Right? That would normally be fine, but not in update because it's working unevenly. So I've moved all of the input in update because we need input to be super precise, right? Mm-hmm. But I have moved all of the physics in fixed update. All right? So let's see what I wrote here. Added fixed update. All physics must happen here because time is fixed. That's a you know what that is? That's a tautology. That's a logical fallacy. I explained something with itself. That's kind of silly. What I meant to say is that all physics have their time fixed. So let's move on. Fixed update. Put all of the checks up here at the top. Important to have this information at the time. So these are our functions that control all of our raycasting. They're all up here. It's very important to have them up there, but before we only had the grounded at the top, and then down here we had up and sides. That I prefer to have all of this information at the top so we can make informed decisions, right? Very important. And everything else is the same with a few changes. So here I've changed all of the delta times to fixed delta time because obviously we're inside fixed update right now. So time scrolls slightly, it's the same time, but it's updated at certain given intervals, right? So that's actually a precise number. I'm fairly sure it's 0.02 F. We can debug log it if you want. Anyway, so this can go. And another thing I've added here is I've added a check to see if the side is blocked while I'm in the air. So let's see how this works. It should already work. I forgot to save, but it should be okay. So, okay, you see our orange friend? Look at the orange friend carefully. When he hits the side of the blocks, he falls right down. But look at the yellow friend instead. He's sort of digging into the thing. right? He's digging in. That's because he's not checking for the obstacle. He notices the obstacle, but it then still keeps applying the forces to go forward, right? Whereas we have fixed that. Okay, so this is what this particular change does. Except this is for grounded, so it does it on the ground.
By the way, you wrote, added a test for side blocked.
Yeah, that's the one. We can remove that. Okay, and this is the same where I changed fix update, and I'm adding a test for the side blocked, but this time in the air. You see grounded is false. Okay, so there we go. And we can remove all of this. And yeah, for the audience who's listening live, little Zoe is homeschooled. She is 9, and she's already fairly capable of reading this code. She may not be able to construct it herself, but she has a fairly good idea what it means. We've been doing this for a while now. We have an entire series already there. Maybe we should show them what we created.
Yeah.
Okay, we'll do it later.
Yeah, after we finish
After we finish the class, that's right. Okay, so here we had if side obstacle block, blah, 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 blah. I've literally taken exactly the same code and changed it to fixed delta time. Okay, so all of this can go. I'll remove this. And this. I'll remove all of the comments. We don't need any of these pesky comments. Save. Okay, so now what we can do, now that we know what all of this does, is we can select it all, copy it, and we're gonna overwrite the player controller. Select all, paste. Now we need to make a big change because otherwise it's gonna cry everywhere. The change is in the class name, right? The class is called Daddy Player Controller as opposed to Player Controller. Save. And you see all of the errors went away. Let's see now if the two characters behave exactly the same, which they should. They will be very, very close. They won't be perfectly the same because errors in float calculations and all sorts of stuff. But you can see they're pretty close, right? Whee! And for people who haven't seen our previous shows, you should know that right now we use no colliders. There are no colliders anywhere. Our character isn't using colliders to do this. We're using raycasts to do this, okay? All right, so let's go back to here. Now we can work only with a player controller. We're not too interested in Daddy Player Controller anymore, right? Let's improve this. So the first thing we wanted to fix, I should probably show again, is the thing that we can slide into
the wall.
Oh dear, that's not nice.
Yeah.
Right. So, and as we said, we already know what the problem is, right? It's the raycast switches to the right automatically because mathematics is biased to positive. So if we move to the left, our stick gives us what value?
Gives us the minus.
-1, right? And if we get mathf.sign from it, it's going to be -1. But positive movements gives us a positive number. But what about 0? 0's sign is also positive, right? So that's why our raycast is pointing to the right. That's very sad. So let's go and fix it. All right, so the first thing we need to do is take a look at our side rays. Here they are, right? So remember what we did last time? We want side rays on both sides, right? We want to point left and right at the same time. Therefore, we're going to need 2 side rays. So put me a comma there. 2 side hits. Only 1 side ray origins because all rays originate in the middle of the character. Padding and length should be the same. And I think that for now that's sufficient. I'm not sure. Do we have anything more? I'm not sure. Save for now? Oh, yes, we do. Of course we do. Here we had a side obstacle direction, which was an int. But now we don't need that. What we need is a bool for left and a bool for right. Correct? So let's delete this completely. And go down here and add a private bool array. She's typing, by the way. Private bool array. And you want to call this one a side obstacle. Obstacles. Let's add the word found. Found. And then semicolon. Save. Okay, so this is an array. These are arrays, so we need to go and correct all of this stuff, right? We're getting loads of errors. So we're going to double click on the top arrow over here, and let's see what it tells us. So it tells us that side array has side ray density as a quantity. That would be good, except we now have how many sides?
We have
How many sides
2
does
sides.
it? Right, so you want to put a 2 there, and then hit comma, and then space, right? So this array is going to have 2 groups of 5 or however many we've picked, right? So here you need to do the same, 2 comma. Okay, so give it a save real quick. All right, so let's grab this, copy this, side obstacles found, and we're gonna put them here, paste them. Whoops, I put a plus, sorry about that. Now open, type equals, new, and you need to initialize it. So how do we do that? New, what type of variable is this?
This is a bool.
All right, so you need to type bool, and then you need to open a square bracket, and how many do we want? 1 per side, so 2. Close the square bracket, semicolon, save. Perfecto. All right, so the origins should already be all correct. There's a bit of complicated math which is gonna make people in the audience go crazy, but we're gonna ignore this because we already did it in our previous class, right? Plus, I'm sure you don't remember what it is. All right, so let's hit Control MO here to minimize. Let's go back to side obstacle. All right, so side obstacle direction is 0. We're gonna have to change that, but before we do that, let's go take a look at our check, because I'm sure this doesn't work. Yeah, it's all broken. Look at that. Okay, so first of all, we need to change both of our side obstacles into false. I don't know that we need to do it here in the beginning, because we're gonna have to loop for both sides anyway in here. So right here, start writing a loop. I is 0. 9.
That is 9.
That's you're a bit ahead of the curve there.
Yep.
Okay, 0. I lower than.
Oops.
Let's focus, please. Lower than. That's higher than banana.
Ah. I also get confused with the way it goes.
Yeah, well, how are you going to survive in this world? Look, I'm joking. Lower than 2, I believe, right? 2 sides. 2. Semicolon. I plus plus. Close the round. Open a squiggly. My wallet is in the way, is it?
That's your phone, not your wallet.
Oh dear. Open around. Close around. Open a squiggly. All right. So we've got all of this. Now this is for the sides. And in the sides, we're going to have to do the loop for each individual ray. So cut all of this and put it in here. Ta-da!
But now there's 2 I's, so we need
I
to
know.
change those to J's.
Before we do this, everything breaks. So let's undo this real quick. So we're going to change this to J, you say, right? So hit Control R twice. Press the letter J. Hit enter. Boom. Now cut all of this. Put it in here. Winning. All right. So side raise J. This obviously doesn't work because it depends on the side. So you need to say I, comma, J.
Oops.
I, comma, space J. J is already there. Potato. Save. Okay, so here we need to be a bit careful because we are raycasting both in the same direction based on movement. That's not what we want. We want to cast based on side, right? So side 0 is which side?
It's the right side.
Brr, wrong.
The left side?
That's right. We always go left to right.
Oh.
Yeah. Remember the way you read comics, potato. Okay, so type if, open a round, I equals 0. Close round, open a squiggly, enter, close squiggly. Else, do your thing. Alas, you can't spell to save your life. All right. cut this. Put it here. Then put it here again. All right, so if we're going left, we're pointing to vector 3 left. Just type left. If we're going right, we're pointing to vector 3 right. No, it already says right. What's right? It's like super right. It's like when the Japanese do plurals. They put 2 of the same word in a row. Okay, so we've got transfer dot position plus side origin. Blah, blah, blah. Yeah, that's good. All right, so we got the rays ready. Now we need to check the physics for the raycast. So here you want to put an I comma j. So I comma space, that's all you want. Here you want another I comma space. All right, and here we're gonna need to check which side is blocked. So whenever we start the loop right here, you want to say side obstacles found. There it is, one down, tab. Perfect, open a square bracket, I.
Oops.
Close the square bracket, equals what? When we start, before we test.
It's
false.
Zero. False. Oh,
It's certainly not 0 because it's a bool, semicolon.
Yeah. If it was still an int,
Save.
then
Copy all of this. So here we're gonna check, paste it here, and put 2 equals. Oh, no, there already is one. Save. Wrong semicolon. Save. Okay, so if the side obstacle has not been found, we're gonna say that the side obstacle has been found. So copy this again and paste it right here and say true. Now we're gonna leave these debugs for now, so put an I comma j space, I comma j space, I comma j space, or rather I comma space, my bad, I comma space. Woo, save. Okay, so we've whittled down the errors to 3. So let's take a look at this. Right, so these are the errors that we have due to the fact that now we have 2 sides. Okay, so let's see what we're checking here. We're checking the velocity of the rigid body. I like this. This is good. We're not checking input. We're checking the velocity of the rigid body. If the velocity is higher than 0, that means we're going to the right. If it's lower than 0, that means we're going to the left. However, watch. Here we're checking the absolute of the velocity x. What does absolute do?
it turns everything positive, right?
That's right. So we're just checking the value. Okay, that means we have a direction for the velocity. We don't know which one. So now we need to check for the direction of the velocity. So here you're going to say if, open round and say rb.velocity.x, x is higher than 0f. Close the round, open a squiggly, enter, close the squiggly, save. Now you want to type else as well. Save. And in here we're going to cut this guy. Actually, no, my bad. Cut all of this and put it in here. So if the rb.velocity.x is higher than 0, which direction are we going?
If it's higher than 0, then we're going right.
Correct. So here we need to check side obstacles found 1. So if side obstacles found 1, square bracket 1. No potato, it's a bool. I'm asking for the element. So square bracket 1. That's right, save. Except here we're checking that we have found a side obstacle and then we're allowing movement. That's not what we want to check for. We want to check that we have not found an obstacle. So put an exclamation mark here. All right, now copy all of this, paste it right here, and simply put a 0 here. Save. Perfecto. All right, so let's see what we got here. Here we're checking for movement input in the air. Yeah, that's because we're applying a force based on the movement input, not necessarily based on the velocity. But if we don't have movement input, we should block it too. I'm thinking. All right, so we should copy all of this. And we should paste it right here. It's a bit of code repetition. I'm not sure how I feel about this. Oh well, so let's see for now. I don't really... Yeah, well, the velocity should... The force should apply, but only if we can. So what we're going to do is we're going to copy all of this. And we're going to put it in here. And we're going to remove this if completely. Okay, hold the shift tab, save. And now copy all of this and paste it here. Save. That's perfect because we're checking the absolute of the movement input, x, right? That it's higher than the controller dead zone. This is for 0, this is for 1. It should work. What does this say? That's the one that we had before, isn't it? Yes. So we can clear this one. Goodbye. Save. And now for the last bit, right here, it says if side obstacle direction is 0, obviously that doesn't apply anymore. We have this piece of code here, right here. So copy this. Oh, undo. Okay, copy. And you can paste it here. So let me see what this does. So RB velocity, blah, 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 blah. So if there is no obstacle, then the velocity is maintained. If there is an obstacle, the velocity is stopped on the X. All right. So what we are going to do is we're going to say this. If there is no obstacle on Z on the left, dude, do you think I can do this? And now put 2 end symbols, Shift 7, space, and now copy.
And
I don't know why you've added a B. Copy all of this, paste it here, and 1. So if there is no obstacle on the left and no obstacle on the right, then we are capable of moving. So copy this, actually cut it. I'm lazy. Cut it. Put it here. And now delete all of this. Okay, save.
We have an extra space up there.
How dare I?
And up there.
Oh, no, another one. Fix it. Okay, save. Look what I found. Another one. Fix it. Save. All right. Another one. Save. All right. So let's see how this performs. Let's see.
Oh, I saw another one.
You saw where?
At the end.
Where? Where?
Uh,
Where? You liar. It was in check sides, wasn't it?
Yeah,
There it is.
there it is.
Yeah. You liar. Save.
Sorry.
You didn't lie. You were sure. You were right. Okay, so here we go. All right. Oh, look. Uh-oh. Uh-oh.
Oh.
Uh-oh.
Uh-oh.
Uh-oh. The previous code can move, but the bottom one can't. And it's very sad, and it's all broken. Oh, I've managed to unsnap myself. Let's see. Yeah, it works on both sides, so you can get stuck when hitting a collision. But it works fairly well for going down. Oh, we lost Mr. Orange. Goodbye. Goodbye, Orange. Okay, so we need to find out why we're getting stuck. Let's go take a look. So, we are getting stuck. We are getting stuck. Check sides. So, side obstacles found is false. Side obstacle found is true. This is working. Focus. And what do we need to do here? So, we block the movement. And then when we're grounded, so we need to check when we're grounded, right? So, if grounded, blah-de-blah. If controller higher than dead zone. Oh! I think I can see what the problem is. We are checking if we're moving the controller. And if we're not moving the controller, then we are doing this blocking. So that only applies to not moving the controller. That's kind of silly. It should apply to moving the controller too. So let's cut this and put it here. Outside of the else and remove this else. Save. Let's try now, see what happens. Dun 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 dun. Oh dear.
Oh dear, badness.
Oh dear. It's worse. It's worse.
Now we can actually walk in.
So it's fairly interesting. What's happening is when I go there, I get stuck, then I press left and it pushes me forward. And then it gets stuck. Okay, let's find out what's going on. I don't remember us having this bug last time, so... So the movement input is higher than the controller zone, and then we're given the movement input and we're pushing things. But then we are forbidding that pushing based on whether we're close or not, and we're not actually accounting for the direction we're moving. So that's a little bit silly. Let me quickly check if it's happening in the air too. Oh dear. Yeah, badness. You should know, people, that children invent words all the time. It's just a thing they do. You have to get used to it. So the word badness is just I mean, it's not really an invented word, but it just makes no sense. But she uses it all the time, so it's kind of charming. Badness. Oh, look, we can't go left. So yeah, the problem happens here too. Look, I'm moving left, but it's not moving. The little yellow guy is stuck against the wall. Yeah, so we definitely did something wrong. Let's try and fix the air one first. Or no, let's try and fix the ground one first. So, this should only apply if we haven't found an obstacle and if we're not going in that direction. So let's see here. Velocity is higher than 0, then we stop. Okay, now. All right, so here is where we're moving, right? But we need to figure out which direction we're moving, because if we're moving in the opposite direction than the obstacle, then it's fine. Okay? So, cut this and put it here at the top. Then cut this. Wait a moment, I'm thinking. If RB velocity, no, none of this matters. Wait. Your dad is stuck. Your dad is thinking. I need to think ahead, but I'm stuck. All right, so this implies we're moving, and that's fine. But it depends on where we're moving. So if the velocity is negative, it should actually work. So suppose we're against the wall and we have an obstacle on our right, but our velocity is negative, or we're trying to at least apply a negative velocity. Wait a moment. I think stuff is missing. Yes, thought so. So this velocity would apply, and then we would add force. Wait a moment. Oh, we made a big mistake. We're adding force here. That's wrong. That's wrong. We have copied it from the other place and we've broken it. Let me undo a few times here. Oh no, all of those silly pesky spaces that we fixed. No, wait a moment. I'm undoing too much. It's bad. I've redone everything for the audience. And here we need to change add force. We need to change it to velocity and ground speed. We have basically lost that. So we are checking here for movement input inside here, but that can't work because we've already set it here. So let's go to this part. Copy all of this. This is going to be wrong, but that's fine. Copy all of this, paste it here. Okay. And here we're checking if the velocity is higher than 0, and then rather it's a value. Then if it's higher than 0, here if there is no obstacle on the right, then we can apply this velocity. So copy this, or rather cut it, and put it in here. Save. All right, now it's correct. And paste it here as well. Save. All right. That should already help. Save. Let's see if we've fixed a few things.
All compiler errors have to be fixed.
Oh, we have a compiler error. Oh, that's not our fault. That's Unity. So we're gonna save a bit of an error. And now we are going to wait. And now the compiler error has been recognized. We're now gonna save again. And now it should reawaken. Awaken! Nice. All right. So now we're fine. Please work. Oh.
Oh, oops.
I can't move it all now. Right, because if the velocity isn't 0, we don't have any movement whatsoever. Boy, am I silly a little bit, aren't I? Okay, copy this. My word. Copy. Paste it here. Type else, enter, close bracket. I forgot.
Oops.
Open it first. My bad. Okay. Space here. No, space, not enter. Undo. What are you doing? Space. Save. Okay, so if the movement X is higher than the controller dead zone, RB velocity goes up a little bit. No, it doesn't. This is where we need to start checking if we have an obstacle found on the side. So copy this, put it in here. So if we don't have an obstacle on our right, now we need to check that our movement input isn't higher. So go, wait, just copy, do this, do if, open around.
Oops, id.
Movement input.x higher than 0. So remember the tab key exists, higher than 0. F. Close round, open squiggly, enter, enter, close. Go else. Save. All right, this is gonna work, I'm quite confident. Cut this, put it in here. And now we don't need this if at all. Hit shift tab over here, save. All right, so we are going to move. If our movement goes to the right and there's no obstacle to the right, then we are gonna move to the right. Perfect. Whew. Now copy this.
There's 2 else's.
Yeah, that's fine. But they're for 2 different things, right? This one is for this, and this one here is for that. Okay, so copy this, paste it here, put a 0, save. Okay, now the movement should work correctly. But now we also need to check, we don't need the cells, we also need to check about velocity. Because if the velocity is in the way, right? We can't move. I don't actually even know why we have this particular command here. I think we can completely remove it. Save. Okay, so if the velocity is higher than x, and if, rather, is different than 0, higher than x, if there's something on the right, if there's nothing on the right, then continue doing what you're doing. So that's fine. But if there is something on the right, so we're going to stop, right? So we're gonna copy this, paste it here, and simply say 0 here, 0f, save. And copy all of this, paste it here, and put it, yes, save. So if we are trying to move to the right and there's an obstacle on the right, stop us. If we're trying to move to the left and there's an obstacle to the left, stop us.
Stop us.
Save for now. Okay, and now let's go check that our grounded movement is working properly. Hop. And still it isn't. I can't move away, right? I get stuck into the wall. All right. Oh dear. I feel a bit embarrassed here, you know? Let's see. If movement input is, if movement input is higher than 0. Okay. So if movement input is higher than 0, that will be we're going to the right. If there's no obstacle to the right, we should apply this velocity. Therefore, the RB should have a velocity. If our velocity is positive and there is an obstacle to the right, okay, so I'm not sure what's happening. Type debug.log, debug.log, open a round, quote, and say hello. Close the quote, close the round, semicolon, without the quote in front. Save. All right, let's try this. So we should get a hello when I get stuck and I'm trying to push right. Yeah, see?
Yeah.
It's saying hello. That's good. So it's saying hello, so we're getting that bit. All right, so once we get here, therefore we test here. Our RB velocity at that point should be positive. Therefore it should be here, and it says if you find an obstacle to the right, then stop us. Otherwise, don't stop us. So it shouldn't stop us. Oh, I can see. Your daddy's a banana. Down here, we are stopping ourselves if the side obstacle exists on both sides. That's silly, because it should depend on where the velocity is going. Okay? So this test over here is actually overriding this one here. So here's what we're going to do. We're going to cut all of this. It doesn't need to be here. We're going to put it right here. Okay, and that's where we're going to have our test. So if our velocity is different than 0, brilliant. If our velocity is higher than 0, if there is an obstacle on the right, you need to stop moving. Okay, if there is an obstacle on the right. So we are going to say, let's see these clamps, what they do. So if this is no obstacles, okay, here we put a 0. So you literally take this and cut it. Whoa, cut it, and put it in here. Else, so if there is no obstacle on the right, open a squiggly, enter, close it, cut all of this, and put it here. Now copy all of this, put it here, and there you were going to put a 0 and save. That's it. Save. Now it should work. Come on, man. Don't let yourself down, daddy. Yes.
Yay.
We're moving forward and backwards.
What about the air one?
The air one I think is still broken. Yeah. I'm trying left, but it's not working. But this one works fine. Now let's see if we can slide in. No, we can't. See that?
Mm-hmm.
Trying to slide in. It's not letting me.
And the other one, in the meantime, is sliding.
The other one should be sliding, right?
Yeah.
Let's see. Oh dear. Poor orange. Okay, so we fixed that.
Look, yellow's way faster than orange.
Is it? I don't know. No, I don't think so.
Well, it was being way faster.
Oh, there's something wrong with the sliding though.
That's funny.
We can slide forever. That's peculiar. I think we're gonna have to check that to see what's happening. We're gonna do it next time. So first, let's fix the air, and then we're stopped for now. Okay.
And then we'll show the games and stuff.
Yeah, we'll see. If we have the time, we'll see what the audience wants, okay?
We'll see.
So let's see now here in the air.
Wait, I think Spilat left.
Well, loads of people left. Shush. We're doing a show, remember?
Yes.
Okay, so RB velocity higher than 0, side obstacles found, etc., etc. This is where we add the force. We actually have to do this check before we add the force. If the side obstacles are, we need to check the movement input higher than controller dead zone, but we also need to check that it's going in the right direction. So if no obstacle has been found to the right, then apply. Well, it depends on which direction we're going, really, doesn't it? So let's see what we did here. So we did this to add the velocity on the ground, but we can't do it the same way in the air because we're adding a force in the air, right? We want it to be smooth. Mm-hmm. So let's see. If there's no obstacle to the right and we are trying to move in a certain direction, and now we need to check that we're also moving to the right, then we can move. If there is an obstacle to the right, we need to check that we're not moving left. So type else here. Open a squiggly, enter, close. Save. Copy all of this. Paste it here. And so you see that here we have two conditions that are the same. What does that mean, Zoe? If this condition is the same in both cases, what does it mean?
It means that nothing will change.
That's right. So we can apply it before this if, right? Mm-hmm. Okay, so in fact I think we can apply it even before this if and before this if. Yes, absolutely. So wow, that's a lot of before. So cut all of this for me, put it here, remove all of this, now cut all of this and put it in here. Wham! All right. So now this one, we can actually do the proper check. So we're going to check if movement.x is higher or equal to controller dead zone. No, rather, higher than 0, f. No, 0, f. hit a space here, save. So if there's no obstacle to the right, copy this, and we are going right, paste it. If there is an obstacle to the right, then only if we're going left, right, we can go there. Okay, so now copy all of this, replace all of this. Now if we don't have an obstacle on the left and we are going left, then we're fine. But oh, wait a moment. If we don't have an obstacle on the left and we're going left, then we don't add the force. So, and we're going right. So save. So let me check the logic here, because I think I'm being silly. So if there's no obstacle on the right and we're going right, we're fine. Else, if there is an obstacle on the right and we're going left, we're fine. But if we're going right, we're not fine. But if we're going left here, we don't know. But we've already checked that the RB velocity is positive. Not really sure about this. I don't think that we even need the velocity to any degree. I think your daddy is crazy. Yeah, remove the velocity completely. There we go. Let's only deal with input. Hit shift tab. One more. Save. Oh, actually, this is for dead zone, but whatever. So if the controller is moving and if the controller is not moving, they should be identical. So I don't even know that that matters. Let's remove this. Save. So if the controller is moving and we don't have an obstacle on the right and we're moving to the right, give it this. If we do have an obstacle to the right, then we can't move. So we're gonna remove this. Now copy all of this, paste it here. If we don't have an obstacle on the left, put a 0, then lower than 0, save. My word, I feel a bit silly. Last time we did so much better, but I lost all of the recording because I'm a banana. Oh, look at that. We can now snap off of the wall. Isn't that cool? Huh? We can jump off of the wall. We can hit the wall here. Now, for the observant people, you may notice that sometimes we stop before we hit that thing. Do you know what that is, Zoe? The obstacle here, right? Sometimes it's before. You see how far we are from the obstacle?
Yeah, I see that.
Why is that?
I think that was because the fixed delta time off happens earlier sometimes.
Not necessarily, no. This is happening because the raycasts are detected almost randomly, and you can see that they are detected here too early. Like, I mean, it's correct that they are detected here. We like it. The problem is that we tell the game to stop when we get there, right? Mm-hmm. And so next time we're gonna focus on fixing that bit. I think that for today we've done quite a bit. Look at our game. It feels pretty cool. Do you want to try it a bit?
Yeah.
Here you go. Try it. Oh. Whoa, except we're sliding in the ground. We're going to have to fix this next time. Hey,
stop sliding in the ground, mister.
Whee!
Bong.
Dong.
Dong.
You're breaking your head into the ceiling.
Red guy's dead.
Poor orange guy.
Yay, I won.
All right, we're done for today. Thanks very much for watching, and we will see you again next time. Bye-bye.
Bye.